Today we're going to talk about absolute value equations and inequalities. So to start off, we need to talk about, well, what is the absolute value of a number? All right, so the absolute value of a number, you're going to think about it in terms of a number line. It is the distance between the number and 0 on a number line. Okay, so what do I mean by that? The distance between a number and 0 on a number line. Okay, let's talk about the absolute value of 3. Okay, if we picture a number line, here's the number 0. And then if I go over here, 1, 2, 3, here's the number 3. This distance is 3 units long. So the absolute value of 3 is 3. What about the absolute value of negative 3? So if I go on my number line, go to -1, -2, -3, how far is that distance? Well, that distance is still just 3 units. It's just in the opposite direction. So that answer is also 3. So the absolute value of a number is talking about a distance, but distances are always positive. So the absolute value of a number always ends up being a positive value. Okay, so how are we going to use that? Well, we're going to have equations to solve that have absolute value involved. In order to do that, we're usually going to end up with 2 solutions. Now, when we go through and solve these, we've got to be really, really careful because some of the solutions do not actually work when you check them. They're called extraneous solutions. So here's our general process on what we're going to do. It's kind of a 3-step process. Step 1 is to isolate the absolute value. So we want the absolute value expression to be completely isolated. Now, many times that will already be done for us and we don't need to do the first step. But if we see numbers or terms outside of the absolute value, we've got to move those around so it just says absolute value equals and then something on the right-hand side. Okay. Then we're going to break into 2 cases. And solve each one. Okay, and the reason we have to break into 2 cases is, say we have absolute value of x is equal to 3. Well, from the previous slide, we know that that's going to have 2 answers. The inside the absolute value could have been a positive 3 or a negative 3 to get an output of positive 3. So we're going to break into 2 cases. We'll talk about how to do that with our first example. Once we solve, we are going to check each solution in the original equation before anything was moved around. Sometimes we'll get to keep every answer that we got. Other times we'll eliminate one. Sometimes we may eliminate all answers and end up with a no solution. All right, that's called checking for extraneous solutions. All right, so let's take a look at the first few examples. All right, we're going to solve and check for extraneous solutions. Now, normally it's just going to say to solve or solve the equation and not remind you to check for extraneous solutions. But since this is new, it's in the directions. Okay, problem number 1. I have the absolute value of 4k plus 2 is equal to 10. So I have absolute value equals. So I don't need to do any rearranging here because I already have the absolute value isolated. So we're on to step 2, break into 2 cases. Case number 1 is we just take the inside and set it equal to 10. Because if I have the absolute value of 10, that will give me positive 10. The second case is I'm going to negate the inside. Negative 4k minus 2 equals 10. You can also think of that as 4k plus 2 would have to equal negative 10. Now, technically, both of these 2 equations are exactly the same. So it doesn't really matter if I negate the inside of the absolute value or if I negate the opposite side of the equal sign. As long as I negate one side and not the other, I will be okay. All right, so let's go ahead and solve the left-hand side. So I'm going to put a little line down the middle here. On the left, I'm going to subtract the 2, end up with 4k is equal to 8, divide out the 4, and I'm going to end up with k equals 2. All right, now I'm not going to write out that much detail from here on out. I'm going to say it as I write it. I'm going to go from this line right here on the right-hand side. So I've got 4k plus 2 equals negative 10. I'm going to take away the 2 and get 4k is equal to negative 12. Divide out the 4 and get k equals negative 3. So now the question is, do both answers work? So I'm going to check my solutions. And when I check, I need to check in the original equation. So checking k equals 2 is going to give me the absolute value of 4 times 2 plus 2. The question is, does that equal 10? Okay. Well, that's going to give me the absolute value of 4 times 2 is 8. 8 plus 2 is 10. So the absolute value of 10, does that equal 10? And the answer is yes, it does. So that means k equals 2 is a solution. The question is k equals negative 3 also a solution? So let's check that one. So now when I check absolute value of when I check k equals negative 3, I'm going to get the absolute value of 4 times negative 3 plus 2. I want to know, does that equal 10? All right, so that gives me the absolute value of negative 12 plus 2. Negative 12 plus 2 is, in fact, negative 10. Is the absolute value of negative 10 equal to 10? The answer is yes, it is. So here I have 2 solutions. Okay, so problem number 1 has 2 solutions. They both work. Let's take a look at problem number 2. See if the same thing happens or if it works out differently. All right, the difference on this problem is that I don't have the absolute value isolated. I have a 2 here and a plus 5 here. That both of them need to go away. Now I'm going to undo the addition subtraction first, and then I will undo multiplication division second. So I'm going to subtract over the 5 and get 2 absolute value of 3 minus 2x is equal to 8. Then I'm going to divide out the 2 and get the absolute value of 3 minus 2x is equal to, is equal to 4. Okay, sorry. All right, so now I have absolute value equal to a single thing. So now we want to break into my 2 cases. So I'm going to do the inside, 3 minus 2x is equal to 4, and then I'm going to negate, okay? Again, I could do negative 3 plus 2x is equal to positive 4, or I could do 3 minus 2x is equal to negative 4. As long as I negate one side and not the other side, I will be okay. All right. So solving the left side over here, I'm going to get negative 2x is equal to 1. So x equals negative 1/2. Okay, and yes, you are going to get fraction answers, so start getting comfortable with fractions. And then the other side, I'm going to subtract over the 3 and get negative 2x is equal to negative 7. Divide out the negative 2, and I get x is 7/2, or 3.5. Okay, now I need to check. Whoops, wrong color. We're going to check. Remember, I need to check in the original equation, all right? So I'm going to do, here, let me zoom in on this to make it a little bit easier to see. There we go. So when I do my check over here, I'm going to do 2 absolute value of 3 minus 2 times negative 1/2 plus 5, and I want to know, does that equal 13? Is this true? So that's going to be 2 absolute value of, come back to that in a second. Okay. So let's see. Negative 2 times negative 1/2 is positive 1. So this is 3 plus 1. This is a 4 in here. So this is really 2 absolute value of 4. So 2 times 4 plus 5 equals 13. And that is, in fact, true because I'm really getting 8 plus 5 is 13. So that works. So x equals negative 1/2 is a solution. All right. And now I want to check the other. Now I'm running a little low on space here, so I'm going to zoom in a little bit more. For my other check, I'm actually going to start at the bottom and work my way up. Okay. So I'm going to do 2 absolute value of 3 minus 2 times 7/2 plus 5. Does that equal 13 is the question, okay? So that's going to give me 2 absolute value of plus 5. Does it equal 13? So inside the absolute value, let's see, negative 2 times 7/2 will be negative 7. 3 minus 7 is negative 4. So this is going to give me 2 times 4 plus 5 equals 13. which does work because that gives me 8 plus 5 is 13. Okay, so both answers work here. All right, and you're going to find a lot of the time that both answers are going to work. All right, so if I zoom back out, there are the first two problems. In the next video, I will solve the next two.